typically a conversion problem looks along the lines of using milliliters and liters and stuff like that. But here, because of all the rates that they're giving us, words per minute, things like that, we know that we're dealing with rate here and unit conversion. And we're going to want to use dimensional analysis, a very important skill to use, not only on this test, but at the collegiate level. So we're going to start off here with trying to identify our given. First off, they want to know what we want to know is that they're asking for us to figure out how many days it would take Tony to read the entire novel. So ultimately, the unit that we want is in days. So we'll keep that in mind, that ultimately we're working towards the unit days. And now we think about what's going to be our given. What's the first value we work with? Well, if we think about all the different totals that they're giving us, like we have a total words in the novel, total pages in the novel, total chapters in the novel, parts in the novel, which one of this is the most important? Well, it would be words that we want to use, because what we see later on is that we're given a rate of words Tony reads per minute. So that's going to allow us to eliminate words and transition us from words, the unit words, into time. And I'll reiterate that when we get there. So our given is 349,168 words. And that's it. There's nothing in the denominator, because that's the nature of a given. And now we multiply it by our rate. And the reason we like that rate that I mentioned earlier is because right now our current unit is words. That's the only one we have. But if we say that Tony reads 250 words for every 1 minute, words cancels out, and now we're dealing with minutes in our numerator. And this is a true statement, because they're saying for every 1 minute that passes, 250 words have been read, or for every 250 words that have been read, a minute must have passed. Now we want to keep getting closer to days. Well, we're at minutes, close enough, or in the right direction, I mean. And so now what's our next rate? Well, we know that there are 60 minutes in every 1 hour. And some of you all may be able to jump like right towards days, and that's awesome. But it's something that in this case it's better to just go bit by bit, at least for me, so I have those numbers down. And we're gonna also see that there's a final step here that it's helpful to first eliminate minutes and just be left with hours, because our final rate is shown here, which is the number of hours he plans to read per day. And what we see is that it's 3 hours for every 1 day. And that's a really good relationship. If we jumped right to hours, we may be confusing ourselves. So hours gets knocked out. We have the unit that we want, which is just days. And we realize that the values now that we want to work with are this, 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 and this, because we want to multiply all our numerators. And in this case, it's 349,168 times 1 times 1 times 1, which is the same. And then you can just divide by every denominator that you see. Divided by 250, divided by 60, divided by 3, and you end up with 7.75 days. And that's closest to B.